To what extent can you calculate the median from a set of data? The median is the middle piece of data when all of the data is in ascending order. This is from the smallest to the biggest. Here are two examples. For this set of data, we've put it from smallest to largest, ascending order, and we can see that the middle number is 15. We can work this out by counting from the outside. So for example, we would cross this one off, cross another one off at the end, and we would work our way in towards the middle until we get to the middle number, which is 15. So the median is 15. If we look at the next example and we do the same thing, we cross off from the outside, working our way in, we can see that we end up with two numbers in the middle. So we end up needing to find the middle of those two numbers. Now the middle of 7 and 8 is 7.5, so the median of this set of numbers is 7.5. You'll notice that if you have an odd number of pieces of data, there will be one median in the middle. If you have an even number of pieces of data, then you'll get two numbers in the middle, which you'll then have to find the median from. Another trick is to add the two numbers together and divide by 2. So 7 plus 8 is 15, and 15 divided by 2 is 7.5. This comes in handy when it's not as easy to see what the median is between the two numbers. Teaching techniques. When teaching this topic, you must reiterate that the numbers have to be in ascending order. So that's from smallest to largest first, before you tackle finding the middle number. If you don't do this, you will end up with the common misconception of just literally looking for the number in the middle. It's also a good technique to either tick or cross the numbers off from the outside, rather than just looking at what looks like it's in the middle. If you do this, it will be a lot easier to work out how many numbers are in the centre, whether it's 2 or 1, and therefore what the median is. The next tip is, if you have an even set of data, so for example, here we can see that there are 6 different numbers. Once you put them in order, you'll find that you get two numbers in the middle. You need to add the two numbers together and divide by 2 in order to find the median. So if we put these in order, 12, 21, 43, 56, 65, and 90, we cross them out from the outside, 12 and 90, 21 and 65, you can see that we have 43 and 56 in the middle. Now this is a harder one to work out what the middle of 43 and 56 is, so instead we use the trick of adding them together and dividing the answer by 2. This gives us an answer of 49.5, so 49.5 is the median. This would have been very difficult to work out without doing this calculation. Deep thinking. Adam says that the median is 7. Why is Adam wrong? You can challenge misconceptions by showing students questions that are wrong, drawing out any problems they have. For example, here we can see that what's happened is they know the median is the middle number, so they've looked at the set of data and they can see that 7 is the middle number. What they've forgotten to do though, which is fundamental, is to put them in order first. So from smallest to largest we should have 2, 3, 3, 6, 7, 8 and 9. And now we can see the median number is actually 6 and not 7. This is the most common mistake that students make when finding the median. Interpret cumulative frequency graphs. Let's first recap on what a cumulative frequency graph is. You start with a table which contains a frequency. Cumulative frequency is where we accumulate the frequencies. For the first one, we just write the frequency. For the second one, we add up the first two frequencies and write that. For the third one, you add up the first 3 frequencies and write that. For the 4th one, we add on that frequency to our running total. We keep going, adding on each frequency until we get a total of frequencies which adds up to the same amount as the total of the individual frequencies. To plot the frequencies, we use the upper bound of each class interval, and we plot that against the cumulative frequency. The cumulative frequency always goes on the y-axis. The variable x, the thing we are measuring, always goes on the x-axis. When plotting this, we should plot a nice smooth curve starting at 0. When interpreting a cumulative frequency graph, there are several things we need to be able to do. The first is to find the median. To find the median, we need to find the midpoint of the cumulative frequency. In this graph, the total of the data goes up to 120, so the median, the middle, will be 60. We go across until we hit our cumulative frequency line and then read down to the x-axis to find the value. In this case, it is 325 hours. Other things we can interpret from a cumulative frequency graph include the quartiles. The median is the middle value, 50% of the data. The lower quartile is a quarter, 25%, so we halve again. Here that is 30. We go across until we hit our line and read down. In this case that would be 275. To find the upper quartile, that is 75% of the data, we add onto the median another 30, as we know that is a quarter of the data spread, and we get 90. This is the upper quartile representing 75% of the data. We read across to the line and then down to see that this is 425. There are several other things we could be asked. We could be asked the number of light bulbs that had a lifetime of between 200 and 400 hours. To do that, we'd find 200 and 400 on the x-axis, go up to the line and across for both values and read off the y-axis how many lie between those values. We can find out after how many hours 80% of the bulbs were dead. You'd find 80% on the y-axis, using the values you have already found, which would be 96. You read across and down, and that is 440 hours. What was the shortest lifetime of a bulb? We need to look at where the cumulative frequency graph starts, and that is at 100 hours. So that is the shortest lifetime of a bulb. Teaching techniques. I start to teach this topic by getting students to plot a cumulative frequency graph. Once they've done that, we can discuss where to find the median. I always link the median to 50% of the data. On this graph, we'd see that as the data goes up to 40, 50% of 40 is 20. We'd find 20 on the cumulative frequency y-axis. Never use the x-axis. This is a common mistake that students make. We go across until we hit the line and then read down to the x-axis, and that gives us 3.2 hours for the median. You should encourage your students to draw on the graph itself, as it shows evidence that they have used the graph itself to find their answers. To find the lower quartile, we are looking for 25% of the data. I always say that a quartile is a quarter, and that is 25%. We are looking for 25% of 40, which is 10. Again, we go across to the line and down and read off the value. Here it is 2.4 hours. The upper quartile is the third quarter. Think of this as 1, 2, 3, 4 quarters. The third quarter is 75%, and that is 30. we draw a line across to the line and down using a ruler and see that it is 3.89 hours. Here I would link in the interquartile range. We need to find the lower quartile and subtract it from the upper quartile. Here we have 3.8 minus 2.4, giving an interquartile range of 1.4 hours. I explained that the interquartile range is the middle 50% of the data. The median is a measure of average, and the interquartile range is a measure of consistency or spread of the data. I would also mention that sometimes, although the scale on the graph may extend beyond the data, students are always looking for the spread of data represented in the graph, not the graph itself. When finding the median, students have to look at the spread of the data and not the limits of the scale on the graph. Deep thinking. Bianca says the median is 200. Why is she wrong? The median is 50% of the data, and we can see that the data goes up to 1000. 50% of 1000 is 500. We need to find 500 on the cumulative frequency on the y-axis. Then we draw a line across to the curve and then down to the x-axis. The answer is 65, not 200. What Bianca has done is a common mistake. She found the middle of the data on the x-axis and then read off the y-axis, giving her answer of 200. To address this, you need to explain the context of what you are doing. The answer will be a score, so you can't start on the x-axis. If you start on the x-axis, your answer will be from the cumulative frequency, which is a total of the number of scores and not a score itself.